I'm going to solve the same problem with the pickup in the snowmobile and the ATV, but now I'm going to use the law of cosines, law of sines method and sketch out some parallelograms to help you set this up. I think you'll see by the time you're done with this why I prefer resolving uh, vectors into components on their axes to the sine and cosine method, because it's a little clumsier when things get to be like this. So again, I'll recreate things here. I know that I have this one force from the snowmobile that's 6,200 newtons. I know I have a force of 6,200 newtons. I have another force, this is from the ATV, of 5,000 newtons. And then my other force here was 24,000 newtons, and that's provided by the pickup. Now, if I want to use this law of cosines, law of sines methods, I have to deal with these vector pairs two at a time. So the first thing I'm going to do is I'm going to take the 6,200 newton and 24,000 newton, and I'm going to find their result using law of sines and cosines. So here's what I'm going to do. I'm going to kind of model this from the point of origin with these vectors. That's 24,000. I know that this is 6,200. I know that this angle in between is 120 degrees. Now, if I imagine drawing a parallelogram, so I draw something that's parallel to that vector, something that's parallel to that vector, the diagonal of this parallelogram up to that corner, well, that's going to be my resultant. I know that this is true because I could slide this vector down here, and that would be a tip-to-tail thing, like a graphical analysis. So I can figure this out using law of cosines and sines if I can just figure out some of the dimensions of this triangle. Well, this vector was 6,200, so this end of the parallelogram is 6,200 newtons. And the angle that's across from the resultant, I can probably figure that out too. If this is a parallelogram, this 120 degrees is matched over here by another 120 degrees. So 120 and 120 is 240, but in a parallelogram, all the angles have to add up to 360. So if I take 360 minus 240, well, I've got another 120. And so divided into the two corners, this is a 60-degree angle, and then this is also a 60-degree angle. So now this tells me by law of cosines that the resultant is equal to the square root of 24,000 squared, and I'm going to leave off the units here just because it's a little bit clumsy, plus 6,200 newtons squared minus 2 times 24,000 newtons times 6,200 newtons times the cosine of the angle in between these two, which is a 60-degree angle. So that is the resultant of these two vectors. Let's calculate it, find out what it is. Here's what I come up with. This resultant here, that's equal to 21,578, and we know the units would come out to newtons. So that's the magnitude. Well, where is it? Well, I need to find what that is and then subtract from 120 to get the angle from the pickup to this new resultant. I can do that with the law of sines. The sine of 60 degrees over the resultant, which we now know is 21,578 newtons, is going to be equal to the sine of, I'll call it alpha, over what's across from it, which is 6,200 newtons. And then I cross multiply and divide, take the inverse sine, and that gives me an angle of 14.4 degrees. So alpha here is 14.4 degrees. Okay, now that I know that, I can deal with the other two vectors. So now that I know this resultant, I'm going to have to deal with that resultant and the third vector. So I'm going to start out with a little sketch here. Here's my resultant from the first two vectors. Its magnitude was 21,578 newtons, and it was at an angle of 14.4 0.4 degrees. Well, I have to add together with that a vector of 5,000 newtons that's 120 degrees from that axis. So I'll make a parallelogram again. So I'm imagining a line here. I'm imagining a line here that's parallel to the 5,000 newtons. And the diagonal of this well, that ought to be my resultant, my overall resultant. Well, this angle together with this angle, the total angle here is 120 plus 14.4, which would be 134.4 degrees, which means the opposite corner on this parallelogram is also 134.4 degrees. And if I take 134.4 and double it, that's 268.8. I'll subtract that from 360, and that tells me that I have 91.2 degrees left. So if I divide that by 2, that tells me what each of these corners is. So that means this corner and this corner of the parallelogram are each 45.6 degrees. Okay, I'm going to create a little cleaner triangle here. Here's my 21,578 newtons. Here's my 5,000 newtons. And I know that this angle here is 45.6 degrees. So I want to find the overall resultant here, R, and I'm going to do that with the law of cosines. So the resultant is the square root of 21,578 newtons squared plus 5,000 newtons squared minus 2 times 21,578 newtons times 5,000 newtons times the cosine of the angle between them, which is now 45.6 degrees. Square root of all of that is going to be the magnitude of my final resultant. So I'll do my arithmetic and find out what that is. Not surprisingly, because we've done this before, 18,429 newtons. 18,429 newtons is the magnitude. Now, here's where this gets kind of cumbersome. I have to find out what the bearing is. What is the heading? I can find out this angle here. I'm going to call this beta. So I've used up alpha. I'm going to call that angle beta. I can find that by the law of sines. So the sine of beta over 5,000 newtons is equal to the sine of 45.6 degrees over R, which I now know is 18,429 newtons. I'll take a similar approach to what I did last time, and alpha turns out to be 11.2 degrees. So what does that mean in terms of where we originally started? Well, it's 11.2 degrees from the resultant of the first two vectors to the final resultant. So I'll go up 11.2 degrees, but that vector was 14.4 degrees from the horizontal, or from the pickup's force. So if I take that 14.4 degrees that the first resultant was towards the snowmobile from the pickup, and I subtract the 11.2 that this resultant is from that first resultant, confusing just to even talk about it, I should end up with 3.2 degrees. And that's lucky that that worked out. And that's encouraging that it worked out, because 3.2 degrees is the angle that we found out with the other methods. This is a lot more cumbersome, I think, a lot more confusing, at least for me. And so that's why I prefer the method of resolving vectors. Or if you had Google SketchUp available, or something that makes it really easy to draw things, graphical analysis was pretty good too.